Okay, inequality, interval and set builder notation. All right, interval notation is where we are headed. We want to do everything for the most part from now on through interval notation. Now, interval notation is a method used to represent a subset of the real number line. Okay, the real number line is just that number line from negative infinity to positive infinity. And a subset just means like a portion of it. Okay? All right, when we are writing in interval notation, we use brackets and we use parentheses. Okay, if I am looking at a graph, okay, solid lines indicate that those values get brackets. Okay, these are my closed circles on a number line. So those circles that are colored in. And my point values here are included. Okay, my point values are included. Now the opposite of being included is that my point values are not included. Okay, now rather than a solid line, what other lines have we talked about in Algebra 1 or whatever? Do what? Dotted or dashed. Okay, either way is fine. So a dashed line, a dotted line might look something like that. That just means this is the guideline, but it's not actually that value. Okay, and this is where I also have open circles. So maybe I have an open circle plotted on a number line. Okay? All right. Down here, we're going to talk interval and inequality notation. Inequality notation, okay, is where we use less than, greater than, less than or equal to, greater than or equal to, or not equal to. Okay? Now, it says let A and B be two real numbers where A is less than B. That just means on the number line, from left to right, your A value is going to come first and then your B value comes somewhere later. Okay? Then A and B are endpoints of four different bounded intervals. Bounded just means like it's tied up to a certain start-stop place. Okay? There, it has an end. Okay, on the real number line as shown below. Okay, now we've kind of done some of this already, but just to start right here, interval notation, this is my brackets or my parentheses. Now right here, it goes from A to B. Every single one of these use A to B. A comes first, and then B comes second. The difference in every single one of these is whether it has an open circle or a closed circle right here. Okay? All right. So this one, A is included and B is included. So we would say it goes from A to B where both of those values get included. Here I have both open circles. So both A and B get parentheses. Okay, what about this one? A gets a what? A bracket, and B gets parentheses. And then for this one, my A value gets parentheses and my B value gets a bracket, okay? This is the notation that we are going to use most often this year, okay? But if for some reason the inequality notation shows up again, I don't want you to not recognize that, okay? Now, my number line is the x-axis, Okay? The number line is the x-axis, and therefore all of this deals with the x values. Okay? So I'm going to put x right here in the middle, and on either side of my x value is a and b. Right here I'm going to say that my x values are greater than or equal to a. You see how I'm reading that backwards? X values are greater than or equal to a, so it starts at a and it goes up. But everything is less than or equal to my b values. So my x values here lie between a and b, and the a value and b value are both included. Okay? Now, I'm going to come up here, and with the brackets, I'm going to put the less than or equal to and greater than or equal to symbols here. And for parentheses, I'm going to put the less than or greater than. The equal to part here shows me that that number is included, but it doesn't have the equal part here, so it's not included. Okay? All right, now this one is going to look similar, except rather than less than or equal to, both of these are just going to get a less than. So I start at A. My x values fall between A and B. Okay? All right, right here I have A, then X, then B. What kind of symbol am I putting right here? Less than or equal to, okay? And what about right here? Just less than, perfect. And then lastly, same thing. This is going to be less than, and this is going to be less than or equal to, perfect. Okay, bounded means there is a starting and stopping restriction, okay? There are limits to where those values go, okay? But I get down here, and then I'm talking about unbounded intervals, okay? Unbounded intervals just mean that somewhere there is no end. So what does that bring into play? Infinity. If I have a number line, okay, the further I move to the left, we are heading to negative infinity. And the further I move to the right, I go to positive infinity. Okay? So, interval notation. Right here, all I have is an a value. And that a value has a closed circle. So what type of symbol is it going to get? Well, for interval notation, those are my brackets, parentheses. A bracket, that's right. All right, and then right here, if that arrow keeps pointing in that direction, the further I move to the right, the bigger it gets. So therefore, it goes to positive infinity. Question. Can you ever get to infinity? No. No. So will infinity ever be included? No. You will always have parentheses with a positive or negative infinity, okay? You will always have positive infinity on the right-hand side because we always write these least to greatest. In a minute, hold on just a second. Always write intervals from least to greatest. Okay, and I usually say from left to right. I'm also going to say right here, start looking at negative infinity and look to positive infinity, okay? Now my inequality notation, I'm going to go ahead and I'm going to write that for this, okay? My x values, my goodness, come on now. My x values are greater than or equal to my a value. So I'm at a. That a has a closed circle. I know that because of the equal to part. And everything is greater than. Okay? Greater than or equal to. Also, if you ever get tripped up on whether it's moving to the left or to the right, okay? Here, this is the direction that my arrow is going to be. Does that make sense? Okay. All right. Right here. What's the difference in these two? I have an open circle. So rather than a bracket to get started, I'm going to have parentheses. So over here, what am I putting in between my x and my a? X is greater than a. Let me put some WD-40 on my table. That's what the table sounds like today. Okay. Now, this one is a little bit different. Uh-oh. Okay. Here my arrow is pointed to the left. Mathematically, the further I move to the left, what do I say I'm headed towards? Negative infinity, okay? So if I'm reading and writing this from left to right, I say that this graph is coming from negative infinity and it stops at B. Well, B has a closed circle, so therefore it gets a bracket. This one is the exact same thing, except it gets a what? A parenthesis. Perfect. Now, right here, we still want to say my x value first, and then we'll put whatever that value is right here. What will I say right here? How do my x values, or what x values am I including in relation to my b value? The ones that are less than or equal to b. Perfect. Here, just x is less than b. Okay? Okay, right here. There are no a and b values right here. This whole thing is shaded. From left to right, we know that if that arrow is shaded, it's coming from negative infinity. There is no stopping or starting right here, so we know it just keeps on going to positive infinity. Infinities never ever have brackets, and we must write these from least to greatest, okay? Can I make a point to say right here, you will never have a positive infinity on the right-hand side, and you will never have a negative infinity on the right-hand side. These are big no-nos. Your negative infinity always comes first, and then your positive infinity comes next. Okay? Now, if there is no break in here, all of my x values are covered. Okay? So right here, I'm going to say that my x values fall between negative infinity and positive infinity. Will I ever include those? No. Okay, we will never include those. Okay. All right, flip it over for me. Okay, I have given you some notes right here over a new notation that you may or may not have seen. Yes, sir. Can you hold on just a few minutes? Okay, I promise I'll let you go in a minute. Okay. All right, set builder notation, okay? Set builder notation uses symbols to define a set in terms of the properties of the members of the set, okay? Now, right here, this is that fancy little bracket. Now, I don't have a easy time of drawing those, but it's the little fancy curly Q bracket, okay? To write a set, to start and end a set, we have these fancy curly Q brackets. Okay, that's what I have right here and right here. Now, right here, inside, it has an X, and then it has this vertical bar, okay? All right, the set of all real numbers, X, the set of all real numbers, X, this bar right here is read such that, okay, X is less than B, okay? So any X values that fit into this particular set, whatever it's describing, just teaching you how to read this, are less than your B value, okay? So here's some other ways that we might see this, okay? Just some other ways to write it. X such that, or sorry, the set of all X values such that your X values are less than or equal to A. You see less than or equal to A here. Or your X values are greater than B. You might be given a graph that you have to write this out for, okay? Now this number line right here, you've got this number line and you've got everything shaded except for this open circle A. So A is the only value on the number line that is not included in your values. So this can be read, the set of all X values such that X does not equal A. Okay? We're going to play around with that again in a little bit. I just want to throw that in here. Okay? If there are multiple intervals to join together, okay, we will use the union symbol. Okay? We will use the union symbol. A union is joining things together. Okay? So we will use the mathematical union symbol if we have to put multiple things together. All right. My directions for these four say, write each inequality in interval notation. Okay? I am given the inequality. I am told that my X values are greater than 3. So that means 3 is my starting point, and everything else bigger than 3 is included. So where is that going to go to? Infinity. Okay? Now, was the 3 included? No. So it gets parentheses, and is infinity ever included?
Never.
No. Never ever. Okay? Right here, X is less than or equal to negative 4. Well, if I'm thinking about less than goes to where?
Negative.
Negative infinity. So from left to right, it's coming from negative infinity, and it stops at negative 4. Infinities are never included. Is that negative 4 included?
Yes.
Yes. So it's going to get a bracket. Okay? All right. This one, X cannot equal negative 2. So that means any and everything else on my number line is shaded in. So let's say here's negative 2 right here. That means there's an open circle, and that means everything else is part of that graph. So it's coming from negative infinity, and it stops at negative 2. Is negative 2 included? Nope. Okay, and then I will pick up on the other side of negative 2, and it goes on forever. Because I have 2 or more things there, I'm going to put those together and say this and this. Okay? All right. Sometimes I feel like drawing a picture helps us with these. All right, this says x is greater than negative 5. So negative 5, and then the other number I have here is a 3. Now, I know that x is greater than negative 5. Negative 5 is not part of that. But also, my value of 3 is not included. Well, if it's greater than negative 5, I'm shading to the right. But when I get to 3, I have to skip over it as well. Okay? So I'm going to say right here that this one goes from negative 5 till I get to 3. Do you agree everything from negative 5 to 3 is shaded in? Neither one of those are included. So both of those get parentheses. And then on the other side of 3, it goes on forever. Do you see how I'm stopping and starting at 3, but because I have the parentheses around them, that 3 itself is never included. It's like an open circle right there, okay? No, this is not on the quiz tomorrow. Okay, great question. I'm not doing that to you. Okay, all right. Now, here we go. I like writing these from inequalities a lot better. I go from 1 to 3. 1, 3. And then I come back and look at my inequality symbols to tell me what to put around it. What am I going to have on either side? Parentheses. Done. Man, that one's so hard, wasn't it? Okay. What about this one? I go from 2 to 5. What does 2 get? A bracket. And the 5 gets perfect. Okay, what about the next one? How will I write that? 7, comma. If x is greater than that, does it ever stop? Positive infinity. All right, and both of these get parentheses. Okay? Ty, you okay? You hanging in there with me? I promise I'll let you go. Just give me a minute, okay? All right, then right here, it says x is less than or equal to 5. All right, first of all, the less than or equal to part, we got to remember that means I'm coming from the left. What is all the way over there at the left? Negative infinity. We write from least to greatest, and I stop at 5. What does the negative infinity get? Parentheses, and the 5 gets perfect.
I have a question. If it's the equal to sign, why doesn't it get the bracket for the negative infinity?
Negative infinity will never have a bracket.
Even if it has an equal sign?
Even if it has the equal sign part right there. Yep. Okay? All right. From a number line. These are easy as well because we should just be able to look at the circles to know bracket or parentheses. Okay? This first one, I go from negative 3 included to what? 4 not included. What about this one? Negative infinity always gets parentheses, and I stop at 3 included. That gets a bracket. Perfect. Okay. The splits. Okay, I go from negative infinity not included to 0 included. But then I have another part that I have to join to that. So I'm going to say union, and what will I put? Parentheses 4 to infinity, parentheses. Okay? All right, right here. I am given set notation. So this reads, the set of all x values such that x does not equal -1. So if I were to kind of sketch this out on a number line, -1 has an open circle. That is the only thing that is not included. So this one's kind of split also, right? I'm going to have two separate things. From left to right, we go to negative infinity to positive infinity. Where's my break? -1. Negative infinity to -1, both not included. And then I go on the other side of -1 to positive infinity. Yes, negative numbers are real numbers. Real numbers are any number that can be written as a fraction or any number that can't. So like pi is still a real number. Okay? All right, now, these last two right here, I want you and your seat partner to try those. Okay? Hey, third hall. Y'all try those real quick. All right, y'all got it? All right, can I have a volunteer? Raise your hand. Tell me. All right, Marquise, tell me what to write for this one. Okay? Parentheses, perfect. Okay, what about the set of all numbers except 100? All right, Braden, tell me.
All right, parentheses, negative infinity to 100, and then that little u thing.
Okay, what do I put with the 100 though?
Parentheses.
Okay, the u thing,
Parentheses 100 to infinity, parentheses.
Perfect. Excellent. This one is very much like the one right above it. It was just given to us in a different format. Are y'all okay with that? Okay, so we're going to get practice today writing interval, inequality, all that stuff notation, okay?